Today we're doing the area of a rhombus and a kite. So last lesson we were looking at the area of a trapezium. We're working our way through all the quadrilaterals. So a rhombus is a quadrilateral. It has four sides, but it's got four equal sides. So a rhombus is like a pushed over square. If you get a square and tilt it one way or the other, you'll form a rhombus. It still has four equal sides. What it doesn't have, that a square does, is it doesn't have four right angles. Okay, now a kite is also a quadrilateral. It has four sides. It has two pairs of adjacent sides that are equal to each other. So if you look at the kite that flies in the sky, this side and this side are equal to each other. So that's one pair of equal sides. And this side are equal to each other, and that's another pair of equal sides. So it has two pairs of equal sides. Now those equal sides are adjacent to each other. Adjacent means next to. Alright, so the sides have to be next to each other. And that's what's happening with a kite. Now both of these shapes have the same area formula. The area formula is area equals a half xy, and x and y represent the diagonal lengths. So if you have a look at a rhombus over here, here's our diagonal. So we need the length of that, and here's another diagonal, and we need the length of that. Okay, so for this one here, the kite, we go from one corner to the opposite corner. That's one diagonal. And from the other corner to its opposite corner, and that's the other diagonal. So they both have two diagonals. So make sure that when you're using the formula that you use the length of the whole diagonal. All right, so in all these questions we're finding the area. So if you look at this question here, this is a kite. It's got one pair of adjacent sides equal, and here's the other pair of adjacent sides equal. So we're using our area formula, our A equals a half xy. So now we're going to sub into this formula. So we've got a half times, remember there's times signs in here, and the two diagonal lengths go in now. Well, here's one of the diagonals, and it's 3 times, and the other diagonal would be here, but they've shown it to you down the bottom here. So the other one is 1. Now you just need to type that in your calculator left to right. Just do a half times 3 times 1, press equals, and your calculator will come up with this. Okay, now you can't give the answer like that, so you use SD or Shift SD to get your answer. Okay, so for instance, if I have a look at my calculator and I've got my answer as 3/2, if I press SD, it gives me 1.5. That answer's okay. Or if you use Shift SD, it gives you 1.5, and that answer's okay too. All right, so you can give the answer as 1.5 or 1.5. The units are centimetres, and it's an area, so it's squared. Okay, so just remember when you get that fraction answer, that improper fraction, you either use SD or Shift SD. Okay, to get your answer. Okay, so we now have a look at B. This one's another kite. We've got a pair of adjacent sides equal and another pair of adjacent sides equal. That means we have a kite. I've already written the area formula down. So now we're just going to substitute our numbers in for our diagonal lengths. Now remember you have the whole diagonal length to put in here. So this diagonal going from here to here is 7 plus 7. So that's going to be 14 going in there. And the other diagonal going from here to here is 20 plus 10. So you're going to have 30 going in there. All right, so just be careful. You've got to give the whole diagonal length. So now you put that in your calculator. A half times 14 times 30, and that will give you 210. Then you write centimetres and squared on the end. All right, looking at the next question, it's got 4 equal sides, so it's a rhombus. So we're using this same formula because it works for the rhombus and the kite. And now we're going to sub our numbers in. So we want our whole diagonal length. The one going from here, 15 plus 15 is 30. And the one going the other way, 8 plus 8 is 16. Now you put that in your calculator, a half times 30 times 16, and I think you're going to get 240. Yes, you'll get 240, and then you put metres squared on the end. Okay, let's have a look at the next one. This is a rhombus. It's got 4 equal sides. So area equals a half xy. We're going to put our diagonals in. So it's a half times, now our whole diagonal's been given to us here, that's 15, so that's okay to go straight in. And the other diagonal going from there to there, they've shown you down the bottom what that is, it's 42. And then we're going to put that in our calculator, and I'm not doing this one in my head, so let's put it in the calculator. So you're going to type in fraction key, 1, down arrow 2, right arrow out of the fraction, times 15 times 42, and press equals, and you'll get 315. So let's put that answer down. Millimetres on the end, and it's squared for area. Okay, the next question here is given it a little bit differently. So what they've told you down the bottom here is PR equals 2.4 metres. That means the distance from P to R straight through is 2.4 metres. So they've given you one of the diagonals. Now I'm not going to mark the other one in, but if you have a look at it, QS, in other words from Q to S, that way, that one is 1.5 metres. So the two numbers they've given you are the full diagonal lengths. So let's put them in. So we have a half times 2.4 times, the other one was 1.5. And we're going to put that all in the calculator and see what the calculator gives us. So we're typing in a half, fraction key, 1 down arrow 2, right arrow out of it, times 2.4 times 1.5 equals, and you get 1.8. And we're dealing in metres here, and it's squared for area. All right, so we're going to look at a couple more questions. One's more application. So I'll just bring it over here. All right, so if we have a look at F at the top here, this one is 4 equal sides, that's a rhombus. So we're using our area formula. So it's a half times. Now we have our full diagonals given to us here. This one's been given as 30, and this one, see the arrows, it takes you from here to here, in other words, it's showing you it's the whole length. So we can put in our 30 for our diagonal length from here to here, and 20 for our diagonal length from here to here. And if you put that in your calculator, you'll get 300, and it's in millimetres, and area it's squared. Okay, next. Now this is like a graphic design question. All right, so this is a fairly famous symbol. It's a logo. Which car has that as its logo? That might be something you can go and have a look at. But what they've done is used 3 kites in their logo. So these are identical kites. Each one's exactly the same. So they could fit on top of each other if you wanted to. So let's look at the question. It says, what are the lengths of the diagonals for each kite? Now all they've given you is that this goes from here to here, that's 20 centimetres. And from here to here, from the top edge to the bottom edge in a straight line is 13 centimetres. So we have to be a bit inventive to try and work out how we're going to get these 2 diagonal lengths. So let's have a look. Well, if you look at this one, the 20 goes from here to here, right? So from there to there. So if you draw a straight line straight through it, you'll see that really this is just cuts it in half here. So this would be 10 and this would be 10 to make your 20. I'm not going to write the units on, but you can see what I've done there. Now going in the other direction is a bit trickier. All right, so to go from the top edge, which is here, top point, to the bottom point, which is kind of lined up with those, we've got 13. Now what have we done to get there? Well, we've gone straight down, and then we did this little bit as well. Now that little piece there, if you move it over a bit, is here. So it's actually half of that diagonal. Now because these are all identical kites, the long diagonal of the kite we already know is 10. So we can go and put that in up here already. We know that's going to be 10. So that means that this little piece left here, if that's all 13, this little piece will have to be 3. That means that little bit there is 3. So how long will that little diagonal be? It would have to be double that. So that's going to be 6. So our diagonal lengths are the red one, 10 centimetres, and the blue one, or the one we were working with the blue on, will be this doubled. So it's going to be 3 times 2, 6 centimetres. So there's the 2 answers that we need for our 2 diagonal lengths. So we need those. So even if you've got no idea how to do that and this was in a test, you just go, well, I'll have to just make something up because I need to continue with this question. All right, so just write something down for the diagonals. So now we're going to find the area of a kite, and we know it's that formula there. So now we're going to just sub in our numbers, our diagonal lengths 10 and 6 like we just learnt. So let's sub them in. It's a half times 10 times 6. And then go to your calculator to work that out. And when you work that out, you'll get a 30. Our units are centimetres, and it's an area, so it's squared. Now that's the area for one kite. We now want the area of this entire logo. And we knew that there were 3 identical kites. So you want to do 30 centimetres squared times 3 of them. You've got 3 of those identical kites. So if you work that out, you're going to get 90 centimetres squared for the whole logo for the area of these 3 kites altogether. Okay, so I hope you understand what to do. It's all with rhombuses and kites. All use the same formula because they both have that same formula, area equals a half xy. So have a practice with it for your homework. At the very least, it's going to be 3 lines of working formula, sub in and get your answer. Good luck with your homework.